Yes, good morning you all. Today we will discuss about a special branch of optics which is wave optics. The title itself indicates optics by considering light as a wave. So now we will discuss about introduction. So before discussing in detail about that, let us consider a medium, homogeneous medium. In homogeneous medium, if this light ray travels in a straight line in homogeneous medium. The study about this light ray by treating it as a ray, which is due to the particle nature of the light, by treating this light as a ray and the traveling or propagation of this light ray in homogeneous medium, the study about this light is called geometrical optics. In this geometrical optics, here light is considered as a ray and it is traveling in straight line. And the traveling or propagation of light in straight line can also called as rectilinear propagation. This is about light by treating it as a ray. The study of light by treating light as a ray is called as geometrical optics. And this geometrical optics can explain about reflection successfully, and it can explain about refraction successfully, and it could explain about this total internal reflection successfully. TRR, reflection, refraction, and TIR, total internal reflection. But the same geometrical optics, what is geometrical optics? Geometrical optics is the study about light by considering it as a ray. So if we consider light as a ray, it could not explain about the phenomena. Which are those phenomena? Interference and diffraction and also polarization. This geometrical optics, which is by considering light as a ray, could not explain these three phenomena. What are those phenomena? Diffraction, interference and polarization. And how can we study about these three phenomena? That is a challenging task. But later, because of the experiment conducted by Huygens, and he conducted many experiments and he suggested one theory. What is that theory? That theory is based on light by considering light as a wave. And we know that most of the students are very familiar about the electromagnetic. Light is a electromagnetic wave. So by considering light as a wave, here we can say by wave nature of light. So by wave nature of light, we can study or we can discuss about these three phenomena. What are those three phenomena? Interference and diffraction and polarization. So these three phenomena can be successfully discussed by considering light as a wave. And by considering light as a wave is nothing but, and that is successful due to the nature of the light. That light has both particle nature and wave nature. So here, by wave nature of light, we can discuss about these three phenomena successfully. And by considering light as a wave, the study about the light by considering it as a wave can be called as a special branch in optics, that is wave optics. And here wave optics, another name is physical optics. So here what is the summary? What is the conclusion? In optics we have two branches. One is geometrical optics, another one is wave optics. Geometrical optics can be called as ray optics and wave optics can be called as physical optics. And because of these two phenomena, by ray optics we can explain reflection, refraction and total internal reflection successfully. And with the help of wave optics, we can discuss about these three phenomena: interference, diffraction and polarization. And this wave theory of light was explained by Christian Huygens. And now this is a discussion about wave optics completely. Till now, we have discussed about the introduction, what is geometrical optics and what it can explain and what is the failure of geometrical optics. And that failure of geometrical optics is overcome by these wave optics. And in wave optics, light is considered as a wave, that we understood. And Huygens wave principle, and another principle is there, that is principle of superposition, that is addition of two waves, are used to explain about these two concepts. What are they? Interference and diffraction. These two principles, or these two concepts, are successfully explained by superposition of the wave. I hope everybody is familiar about the superposition of the waves in waves chapter also. And electromagnetic wave nature of the light is helpful, and it is used to explain about last phenomenon, that is polarization. Now in wave optics, these three concepts are very important: interference, diffraction and polarization. In ray optics, three concepts are important: reflection, refraction and total internal reflection. But here again doubt, most of the students are very confusion. When should I use ray optics? When should I apply ray optics, and when should I apply wave optics? This is the confusion part, and that we are going to discuss today. Suppose if I get a challenging problem in JEE, that problem should be solved by whether ray optics or wave optics. Whether I should treat that problem by considering light as a particle or ray, or by considering light as a wave. This is challenging job. So to eliminate the confusion among these students about the application of ray optics or wave optics to a particular problem, we have a technique. That technique, now we will see that condition for applicability of geometrical optics and wave optics. See here. Suppose size of the object which you are interacting with light. What is the size? Suppose source is the bulb or sunlight. That is the sunlight from sun light is coming. And object means this is an object, or a bottle may be object, or a chair may be object, or a human being may be object. If the size of the object, interacting with the light is much larger than the wavelength of the light. Suppose we know that the wavelength of the light may be in terms of the nanometer, micrometer or Fermi, and size of the object, first suppose if you take a chair is larger, very large when compared to the wavelength of the light. So chair can be treated as, or about the chair you can study in geometrical optics. Suppose if you take hole of a camera will be having a small hole, and in camera hole, or if you take a aperture, or if you take a small hole for any window, or small hole for any object, or small hole for any screen, that hole size may be very small, or it may be very equal to the wavelength of the light. In that cases where the size of the wavelength or size of the object is very small or comparable with the wavelength of the light, in that case you can use wave optics. And simply bottom line conclusion is, for larger objects which are interacting with the light are dealt in geometrical optics. For smaller object, if the size of the object is very small when compared to the wavelength of the light, then that can be dealt in, or that can be studied in wave optics. Right? Now suppose mathematically how to handle, if small b is the size of the object interacting with the light, and if L is the distance between the object and screen, and if lambda is the wavelength of the light, then if b square, that means size of the object, by distance into wavelength of the light, if b square by L lambda is very greater than 1, then this can be handled with geometrical optics. Suppose if it is if it is very small or equal to the wavelength of the light, this b square by L lambda, then you can use wave optics. This is very important, and b square by lambda L is greater than 1 or very large when compared to the 1, then you should use geometrical optics, and if it is very small or equal to 1, then you should apply wave optics here. This is the applicable condition. Now, and here you should note down here, most of the students, you may think that interacting object, what is that interacting object? That interacting object may be, and just now I explained one child. So similar to that, what is optical object which we are dealing? See here, first one is the mirror. Okay, this one is mirror. It is used to discuss about the reflection property of the light. And next, lens. Next, prism. And here, see, pinhole camera, aperture of the pinhole camera. And next, this is what we call slit or straight edge. And this we will discuss about diffraction concept when we discuss about the wave nature of the light. And these are the few examples of the objects interacting with the light: mirror, lens, prism, aperture, or slit and straight edge. These are the few examples. Now, later Newton discussed about the corpuscular theory. Till now, we discussed about by considering light as a particle, by considering light as the wave, and now we will discuss about Newton's study. Newton discussed about light by considering it as a corpuscle. What is meant by corpuscle? Newton thought that light is made up of tiny and elastic and lightweight particles. Light is made up of a particle, and that particle has nature of elasticity, and it is very light. It is not heavy, and it is very small, tiny. And these size of particles are called corpuscles, like dust particles, and which are emitted by a luminous body like sun. And these corpuscles travel in a space with the speed of light. What is the speed of the corpuscle? It is equal to the 3 into 10 to the power of 8 meters per second. And these corpuscles carry energy along with them, and these are called as energy pocket also. And when they strike a retina, we will get, retina means retina of the eye. When that corpuscle strike this retina of the eye, we are getting the sensation of the vision. And let us see here, suppose from sun, you are getting, from this sun, we are getting corpuscles. Corpuscles are strike this plant, and from this plant corpuscles reach the retina of the eye of the child, and so that that child can able to see, and she could get the sensation of the vision of this plant. This is about Newton's corpuscular theory. Now, these Newton or these corpuscles of different color are of different sizes. Red corpuscles are larger than the blue corpuscles. These corpuscular theory explain that light carry energy and momentum. Light travel in a straight line, and propagation of light in vacuum. It could explain successfully light can travel in vacuum also. And it could explain successfully about the laws of reflection and refraction. The corpuscular theory failed to explain about interference, diffraction and polarization. Why? Because here the light is made up of particles. This is due to the particle nature of the light, and due to which we can't study about these three. And next, the major prediction. What is the major prediction of the corpuscular theory? It explained that speed of the light in a denser medium is more than the speed of light in a rarer medium. This is a major drawback. It leads to the failure of the Newton's corpuscular theory. But we know that in your 10th class standard also you might have studied about the refraction. There you have studied that the speed of the light in denser medium is less than speed of light in rarer medium. When light enters in denser medium, the speed becomes or speed is decreased. That is actual practically we could know. So, but Newton explained that in denser medium the speed of the light is more. So, this leads to the failure of the Newton's corpuscular theory. So, finally, the truth that the speed of light is smaller in denser medium. Therefore, the Newton's corpuscular theory is assumed as or treated as wrong theory. So, now finally, for for wave optics, what is the theory base? Huygens theory, that we will discuss next. Okay, thank you.